Cisco is a sponsor of our ebook series on the Docker and container ecosystem. Learn more about Cisco's perspectives in our latest ebook about monitoring and management. It's available for download now at thenewstack.io. Hi, this is Benjamin Ball with the New Stack. I'm here today with Ken Owens, CTO at Cisco. We're talking about container monitoring for our upcoming ebook about container monitoring and management in the Docker and container ecosystem. Ken, how's it going today?
I'm doing great, Benjamin. Thank you. Always good to be with the New Stack. I enjoy spending time with you guys. So thanks for having me back.
This is, I think, now the fifth ebook podcast we've done. So we're starting to rack them up. So we're talking a lot about monitoring today. That's really the primary focus of the book. It's the fifth book in the Docker and Container Ecosystem series. And it's sort of a fifth topic for a reason here. It's sort of the late stage, I think, of adopting containers. It's something I've, I think, learned more and more about, that it's maybe even one of the hardest parts anyway, because it is sort of the last thing that you're doing when you're adopting containers. So really kind of the first question I have is really about what's different when you introduce containers into this monitoring landscape. We talk a lot about monitoring in general, I think, and it's sort of a lot of people would say well understood some of the difficulties in monitoring applications, systems, and say VMs as well. But I really want to know what you think changes when you introduce containers.
As I thought about this question, Ben, I kind of think of, application monitoring is very well known and understood. And the idea of application monitoring is sort of looking at the processes and the performance of those processes to kind of detect and isolate any sort of abnormalities or shortcomings of the performance or the end user experience, right? Network monitoring is also something that's very well known. It's more of a science now than, I'd say, application monitoring is more of a kind of an art, whereas network monitoring is more of a science. Containers is sort of interesting to me, and what's different here in general, before I get to specific differences or specific changes, is that containers are a small unit of capability that results when you decompose an application into a set of services. And then those resulting services, you kind of create a set of microservices which you instantiate as containers. And so connecting these together, managing these, and understanding the availability and the reliability and the translation to these different small microservices which make up an application is much more complicated and much more difficult to do than what we've had to be able to do in the past. And I kind of look at it, and like I said before, in these three areas. One is just the sheer amount of data. When you get metrics for like 20 VMs, you translate that to, containers, you might have 1,000 containers, right? And so what used to be just monitoring 20 different instances now become thousands of instances to monitor. The other piece is that containers get recycled, right? And they move around quickly, or they're just destroyed. And these operations are not they're short-lived in general. And so how do you sort of manage these conditions that are more like race-like when you have a very limited period of time to actually detect the problem? And then the last one is that the correlation of the services and the complexity of the correlation of those services. And I think that's especially true when you think about how quickly the number of services can grow into the thousands of services. Trying to correlate an issue between any given set of services becomes an n-squared problem very quickly.
These kind of seem to be a lot of the issues, I think, that reflect containers a lot in general. Basically, it seems like all challenges stem from a lot of these points. The fact that it's happening at scale, that containers are relatively short-lived, and that there's a lot of complexity in having numerous services. Is this something that when we talk about a lot of these same issues with microservices, Would you say here that when people talk about monitoring microservices, that same kind of logic applies to monitoring containers?
I think you kind of have to look at the sort of a services architecture view of microservices, because to me, like, containers are more about a specific given instance of a microservice or a part of a microservice, right? Whereas a microservice is really the combination of all of these different containers working together and being orchestrated together to deliver an application. And so to me, the level of complexity goes up when you talk about microservices versus individual containers, because whether or not a container is up is easy to determine. What the impact of that container not being up is the microservices problem that's very difficult to determine.
The data that you're looking to collect from the application, is that different significantly, or is it the case where a lot of the what we're looking for is the same, we just collect it in a different way?
Yeah, I think it's more, I look at it more like a superset. So some of the data that you collect from a container is very similar to what you would collect in a VM. I think where and then that's sort of stuff like memory and CPU usage and kind of the status of the service that's running or the process that's running. But where I think it is a little bit different is that the microservices or the container model sort of wants you to start looking at different aspects that are more application specific around, the network traffic, the type of response times you're getting for the service, the interoperability for the data and where that data, how you get access to that data. These sorts of more complex distributed systems problems come into play. And I think that's where you get to that complexity of the application monitoring, but you're doing it at a finite set of individual services that you have to now correlate. So that's where you sort of get to that complexity, is really, like we mentioned, and like you mentioned, like we mentioned in the beginning, right? That correlation of this data and this amount of information you're collecting for the monitoring is being done across a set of different endpoints and systems and services that are in themselves short-lived and difficult to understand what the dependency is between them.
So this is something I've kind of been asking a lot about, and one of the points that you mentioned earlier, because of containers being short-lived, what really is the approach to monitoring them if you're not really sure that container is actually exists at that point or not? Is it more about monitoring the relationships between certain sets of containers, or I realize there's a difference between monitoring a single container and monitoring a bunch of different containers that are doing related things.
There's a couple of different approaches for kind of monitoring containers. I think, the first thing that you want to sort of understand is what I like to call sort of the control plane, or the ability of the services to provide you with that data. And so being able to understand the health and the connectivity model between the services, and think about it sort of like a control plane problem. Like, how do I understand what these components are? And this is very difficult because it takes a lot of, in my opinion, it takes a lot of training, if you will, because of the lack of visibility that's built into these systems, because you're using a bunch of disparate components to kind of build these services. Just understanding these basic service assurance aspects and the health and issue and problem management type of space, right? It's not easy for to get to a really good understanding of just what are the basic monitoring points of interest in this environment, right? And so I think the learning curve is pretty high in order to sort of understand, when you request the service to be deployed, there's a lot of individual systems that get hit. And there's not really there's not much of a feedback loop today to tell you when this container is spinning up incorrectly or has spun up and you didn't expect it to spin up this way. If when it spins up, if the services are all up and available and responding the way they should respond, right? It's sort of a fire and forget sort of model today. And so, while on one hand it's great that you can sort of automate and orchestrate these set of services, in very unique and interesting and high performing ways. It sort of becomes a very complex problem to solve when something breaks, because it's very difficult to identify and isolate those problems.
So that points out one of the challenges, I guess, then, which is not only making sure you're collecting that data and actually understanding it, but knowing how to go back and fix something when something is wrong, essentially.
Right.
That's
and
something.
I think the next step with that, Ben, is like, how do you even, like, to me, it's a lot of what I've been trying to do is like identify these patterns, because if you think about, system theory, going back to my system theory comment, right? Every application has a known pattern. And so therefore a microservice, which is a set of services to make up an application, would have a set of similar patterns, right? Because the application pattern better equal the patterns of the individual services that are giving you that application, right? And so it's kind of like a duh statement, but I think it's a really important statement, because if you understand the application pattern you're trying to achieve, you know how to monitor that pattern. Now you just have to understand how to apply the monitoring points that you need. How do you get that into that microservices infrastructure component tree, so that you can actually get the telemetry you're looking for to deliver that end result that you need for the business.
The application pattern way of thinking about it that you mentioned is actually reminds me a lot of some of the topics we discussed in the last ebook around container security. And that kind of one of the propositions was that if you know what a container is supposed to be doing, and you look for it to be continually performing that set of tasks or that behavior, you're really just looking for spotting the difference, essentially. Is it sort of like that, where you're essentially looking for a predictive behavior?
That's a very valid statement. Like, there's a lot of predictive behavior in here that you're looking for. I think the common, and some people call this a corner case, but in my experience, this is a common use case. It's not a corner case, right? Is the slow response time, or my application isn't responding or doing what I expect it to do, right? Those sort of like issues and problems happen often, right? And so being able to I kind of understand why the performance isn't the way it should be is something that I think, a lot of big companies have spent a lot of money with application performance monitoring, APM side of solutions to try to help solve that problem. But that doesn't really apply, in my opinion, to containers, because containers are still sort of, too many levels of complexity below what the APM tool is looking at and looking for, right? And so, to me, I think there is sort of the area that is common is in this pattern detection with known patterns, and the area that is unique, it's this: how do we evolve monitoring for containers to address more of this microservices application awareness and performance model, kind of like an APM light sort of model that helps you tie the application services back down to some of the underlying componentry that you already have in place that is based on known patterns, so that what you're really focusing on is the anomalies that you can detect pretty quickly with the analytics capabilities that we have today, but not really focusing too much other than where to place these solutions in terms of the pattern recognition, right? Because most of the patterns, like we talked about, are common. So you can sort of identify the locations to place the solutions that you want to work on or work with for your monitoring. Allow that to detect your set of well-known patterns, and then focus your efforts on more of that next level of what kind of analytics do I need to generate and analyze in order to get to this behavior analysis piece that I want to get to.
Yeah, that sounds very familiar, essentially. And you mentioned APM, and I'm kind of glad you did. Application performance monitoring is sort of, in a lot of ways, what I've thought about as traditional monitoring. It's the monitoring subject that I'm used to hearing about. And so when we segue into container monitoring, it was strange to get out of that mindset of thinking about application performance and thinking about there's different things to target here. And there's
Right.
really actually a different level of monitoring going on entirely. You mentioned it being kind of different levels of abstraction away from application monitoring. So that's interesting for me to hear. It seems to validate a lot of what other people are saying. Is this something where you think it's a fundamental difference from how maybe traditional monitoring vendors have approached the subject?
Yeah, I think it's, there's definitely a school of thought out there with traditional monitoring vendors that they can just kind of, you can leverage their existing solutions and get good enough monitoring data to manage a container or microservices approach. In my experience, I haven't had really a lot of luck with leveraging the existing monitoring solutions in this space. At the same time, though, I don't think this industry has the luxury to sort of go off and build and consume new monitoring services. Although there are some good open source projects, to take a look at, like Prometheus. But at Cisco we use cAdvisor for a lot of our container work that we've been doing. So there's definitely projects and things out there to look at. But to me, the key with that, whether it's your existing infrastructure monitoring solution or your application monitoring solution, or it's this new open source tooling, or a combination of the two, I think the most important piece of this is the integration and tying these things back into the systems that your ops teams understand. And if you can't tie it back, then maybe providing some kind of a single pane of glass or some type of a solution that lets you, bridge the gap between your existing tooling and the new container type of tooling that you may need, in my opinion, is sort of an important goal for an enterprise to have. How do you sort of provide both views? Because you need both views. It's not a single view of this problem is going to solve it, right? You're going to need to sort of correlate and bring together multiple different solutions that you have in place to kind of help identify the right issue that you're trying to address.
Yeah, and you're getting into a topic where there's, I think, a lot of complexity too. You mentioned both cAdvisor and Prometheus, both open source solutions we hear a lot about. We've talked a lot about Prometheus recently, and probably we'll talk more at KubeCon. It's something where seems like there's a lot of solutions, and that maybe there's some difficulty in knowing what solutions are going to work best for you or work best for your stack or whatever actually you need to target. You mentioned cAdvisor. I wonder if you have any advice for people who are thinking about what tools are going to actually benefit them. You mentioned integration, and it seems like that's kind of the number one point, is you want whatever solution you pick to actually fit in with what you're using and what you seem to think is important.
Right. Yeah, and then definitely, include your ops team in the discussion, because they're going to have a very specific point of view on what they need to be able to see and how it needs to fit into their existing dashboard, right? Because the last thing you want to do is take somebody's job that's already a complex, difficult job and make it even more complex and difficult, right? And so be conscientious of your ops teams, whether it's DevOps or ops, right? They're doing the same job, right? They need to be able to kind of understand the information that's coming in to make enough sense of it to make a decision when they need to. And so I'd say, that's the second advice I would give. I think the third piece of advice is don't try to overthink it too much, right? I think I always kind of joke back in my previous days in working with the service provider industry. We were trying to create a cloud service offering, and the way we structured our service, we could put, at the time, this is about 7 8 years ago now, we could put about 25 virtual machines on a physical host. And that was with those subscription factor we were comfortable with. And when we put all of our monitoring and all of our event collection tools and all the security agents and all the things we needed to really harden and make sure the environment was the way we wanted it, we were down to about 10 VMs we could put on a physical host. So 15 were for management and monitoring and security, and 10 of them were for customers. And so it was like a joke that I started kind of telling people that if you overkill this solution, you basically, hurt your performance, you hurt your availability, and you hurt your ability to make money, because you're spending all of your CPU and memory cycles supporting the environment that you're trying to make high performing in the first place, right? And so don't overthink it too much where you have to have the exact same heavy solution in every place. Try to architect in a way that you can, leverage commonalities, leverage the network, for instance. If you create the right sort of network environment, you could probably put a monitor in your network that would give you 80 to 90% of what you need for that environment, and you don't have to touch your servers or touch your services at all, right? And so I think there are basic lessons that we've learned in the past that we should apply to containers, because it's the same sort of environment, right? It's all very much a connected and heavily utilized compute environments with big networking pipes in them. So take advantage of what's there and try not to overthink it.
In the process of not overthinking it, is part of that actually choosing different solutions or choosing different tools when you need essentially a different result? This is something we've talked about where people are actually using a couple different monitoring tools, essentially targeting different things. Is that related at all to what you're talking about?
It is, yeah. It's definitely related to what I'm talking about, in that, if you have a good monitoring solution in place today, there's no reason to rip it out and try to replace it with 5 or 6 different tools, right? If it gives you if it does a good job today, leverage it and just augment it where you need to. And to your point, right? There's sort of 2 schools of thought, and I'm probably more in the school of thought you defined, which is, find the right tool for the right job. I'm very much one of these guys that says if you need to monitor X and this solution will give you the best solution for monitoring X, and you really want that monitor X, then get that tool, right? The other school of thought is, good enough, right? The good enough school of thought, which is you can just get one solution and you'll get, they say 80%, I think it's more like 60% of what you need, but you'll get, enough of what you want to look for. And the rest of it, you'll just have to have your really smart guys dig into the problem and spend days to try to figure out what the problem was and fix it, right? And so, I think to me, that's sort of how I classify those 2 schools of thought. The one that's the right tool for the job is going to save you time and energy and effort to solve problems. The one that's a good enough school of thought is going to require a lot more intervention by humans to try to figure out complex problems.
And that does seem to be some of the factors that go into the discussions, like build versus buy for different monitoring solutions. And that's something that I think hear people talk about a lot, which is essentially would a package solution be better for me? But lately I've been hearing this question more as what should I build and what should I buy, and rather that it's not I'm either going to build everything open source or buy one big package. I might use a combination of things.
Right. Well, I every time I have this conversation, I like to it always reminds me of the conversations I have with my kids, right? And the conversation, no matter sort of what the topic is, it always sort of comes back to just because you can do something doesn't necessarily mean that you should do something, right? And I think that's advice that we should all consider very carefully when we make these choices, because these are not single decision metrics, right? When you decide to put a solution into your environment that's going to do a certain function, that function is going to be there for a period of time through lots of changes, through lots of environmental impacts and effects, right? And so I think when you make these decisions, go into them knowing that you're going to have to, if you're going to do this yourself, you're going to have to update this on a pretty regular basis. You're going to have to keep track of security vulnerabilities and issues that come up in the community. You're going to have to take on some of the hardening that, open source projects don't take on for you. If you buy a solution from a vendor, you have to wait for them to patch things or for them to come up with a new release. And sometimes their new releases are not, compatible with the old releases, right? And so there's never a really easy, one answer for all. But I think thinking through the problem and knowing like which side of the fence do you fall on? Are you going to do something that is good enough? Are you going to try to do something that's the right solution for the right problem? That definitely, that build versus buy, I think definitely feeds into that same thought process and should be a big part of the consideration, because it could definitely change your view on that very quickly.
So you mentioned Cisco using cAdvisor earlier. I was going to ask if there's any Cisco specific perspective on how to go about monitoring containers, or if there's anything that you're actually working on that relates to monitoring.
I think that there's a couple of perspectives, from like kind of the Cisco worldview, if you will. I think probably the first one is when you deploy, like we did this open source project Mantle, and when you build and deploy and start running a microservices environment, and you start developing applications and deploying those applications into that environment, there's probably nothing better in terms of like finding the problems and the issues and the lack of visibility that you have in these environments than when you start using it, right? And so we have kind of what I like to call on-the-job experience with, here are the problems you're going to run into when you try to deploy, microservices into any environment, right? It doesn't matter if it's a public cloud, a private cloud, or do-it-yourself, model. You're going to run into these same issues. And so there are, specific things that we try to monitor within the microservices container control plane itself. And we've isolated the control plane from the data plane. So in general, when you think about microservices and containers, you think about flat networks or overlay networks, and you sort of lump the control and the data into the same flat space, and you have this big IP address that you sort of push out to anything external from that server environment. And from a monitoring solution, if all of your microservices are sitting behind an IP range that I don't get access to, it's hard to determine what services are up, what services are down, what problems you're having inside that black box to a monitoring solution. And so I would say the more you can isolate, the more you can provide a real IP address to the key services and the key control plane components of your pods that need specific monitoring of actual services you depend on for delivering or orchestrating within that environment. That to me is probably the number one key lesson that we've learned, that you need to make sure you have really good monitoring on the control plane and the components that make up a microservices deployment architecture. The second thing then is, I think the other piece that's not as well understood with containers has to do with the networking and how these services are discovered and how you consume and kind of compose different services together in a set of joint, loosely coupled, but still sort of dependent on each other way to deliver an application. And the networking piece is something that we've spent a lot of time, obviously, at Cisco, looking at, things like Project Contive and FDIO, Virtual Packet Processing, open source project, to sort of look at how do we bake in just very, like for a network administrator, for a network team, they're going to see the same types of metrics and the same types of data available to them in a containerized model as they would in a physical model, because to me, and I've mentioned this in previous podcasts, right? There is no container networking. It's just networking. And so networking needs to look like networking, because if you have to do special networking, then you're in trouble, because anytime you do something special, we all know that that's going to be a problem. And so we're doing a lot in open source to try to ensure that networking acts and looks and smells like networking, whether you're running in containers and virtualization or in a physical node.
And that makes sense, and that does, as you say, kind of harken back to some of our previous discussions. Is there any basically anything you would point out about Cisco's customers, maybe any of the challenges they've been having as they've gone to monitor their container environments?
Yeah, definitely. We've had quite a few customers sort of working not just with some of the Cisco open source, but just in general with with Mesosphere, with Docker, with CoreOS, with Ranchers. We've done a lot of work over the last year and a half with several of our customers that are going down this journey towards cloud native. And the challenges that seem to kind of bubble up to the top is for them, it's a lack of visibility of what's happening under the covers. They say that there's a lot of basic service assurance aspects that are missing. And so like the health of an application is unknown. They can get health of an individual service, but they can't really get health of an application in these environments. Things like issue and problem management become very complex for them. They don't really have a good way in a containerized world of applying some of the basic best practices around operating an environment. And so that's been probably the top complaint, I would say. And then I think, as I kind of mentioned earlier too, the biggest issue I hear from our customers, and it's pretty much common across all of them, is that it's very difficult to sort of, get to the base level of running an application or a set of applications in this sort of a model. It's a very steep learning curve just to get to that basic level of understanding the flows. And then once they get to that basic level of understanding the flows, it's not obvious to them where they should be monitoring different interests, right? Some of the interest points that they want to look at, or where those interest points should lie within that architecture, it's not obviously apparent to them always where they should put those monitoring components. And then it's sort of we'll try it here, see if it works, see what the output is, see if we can make value, if that solves our problems. Oh, that didn't solve it, let's put it here. So those are sort of like the main challenges they faced. Just to kind of as an aside, I think it's important though, one of the things that we started doing in our open source project was we started doing synthetic monitoring. And the point of that was if you think about these different systems that are interacting in order to, from the moment you say deploy this set of containers, there's a number of different services that are in the control plane that are set up to go and actually execute those commands. And so what we did was sort of started doing synthetic monitoring, and every single action that could cause a change in that control plane, we would exercise that synthetic monitoring event very regularly, so that we would know if something started to degrade or if a service started to have memory leaks that was causing it to sort of have a slower or longer response time. And it really improved our reliability very quickly, because we could identify issues that were about to happen, and we could basically shut down those services and spin up new services so that we never ran into those issues, and we could automate that whole process.
That makes sense. And basically, I think one of the other things I wanted to ask about is there anything sort of on the horizon with Cisco? Is there anything you're working on that's related to container monitoring? We've talked about in the past the acquisition of ContainerX. Is that something that might be part of the future pipeline?
Yeah, absolutely. So the ContainerX acquisition that we just completed was very much around looking at the space of of the concerns that our customers are talking about with containers. And just so you know, there was like a study that Red Hat commissioned not too long ago with Forrester, which kind of talked about the top concerns. And management was, 61% of the responses were like, well, the management of the space is difficult. And I kind of lump monitoring to some degree into that. There are other things like, performance and integration that were just as high that you could say were, parts of the monitoring solution too. But, the whole point of what Container X was doing is they kind of were looking at this space from I would say sort of an enterprise window or enterprise view, looking at kind of, the way, the monitoring and the operations teams need a single view or a single pane of glass in terms of what's happening within this container space. And so, one of the reasons why we acquired them had to do with not so much the product that they had, but the way they thought about ensuring that the monitoring and the management integration between what's new with containers sits well with what's existing in the enterprise today. And so I think you'll see in the not too distant future, you'll see some plans released from Cisco on what we plan on doing in this space, with, kind of the bringing together of Container X with the work that my team was doing on Mantle, with the work that the networking team was doing with Contiv, where you're going to see sort of this all come together into a coherent set of open source solutions or projects, if you will, plus some products that will be able to sort of meet the needs of our enterprise customers.
Definitely really excited to hear about any news that relates to that. I think that's going to be really interesting, and I'm sure we'll talk quite a bit about that when that happens, and if that's something that develops in the future. Definitely really excited to see how that all integrates together and offers a full package. So
yeah, it's gonna be fun.
Yeah, great. Well, thanks so much for talking to us today, Ken. We've done this quite a few times now, and it's starting to feel pretty familiar.
Great. Thanks for your time again, Benjamin. And I'm always happy to spend time with you guys. Keep up the great work.
All right. And thanks for listening to NewStack. We'll talk again soon. Cisco is a sponsor of our ebook series on the Docker and container ecosystem. Learn more about Cisco's perspectives in our latest ebook about monitoring and management. It's available for download now at thenewstack.io.